Hello friends, I am coming with question number 21 and it was a wonderful question. Particle A moves with a constant speed 2 meter per second on a circular path of radius 4 meter. Whereas particle B moves on a straight line coinciding with a diameter of the circular path maintaining a constant distance 4 meter from the particle. This line is very important. The maintaining the constant distance 4 meter from the particle A. Which of the following conclusion can be drawn? Maximum speed of B is 4 meter per second. Maximum acceleration of B is 2 meter per second square. During one revolution of A, the distance traveled by B is 32 meter. Modulus of velocity of particle relative to the other is constant. So let's see what is happening in this question. If I'm drawing, this is the path of A. Okay, and B is going only in diameter. It is given the B moves on a straight line coinciding with the diameter of the circular path. So suppose if any instant, if you see the block is here, so at any instant, if this B is moving with the velocity VB or some acceleration, and here this is moving with A is moving here along the circular path with a speed of 2 meter per second. Of course, we can say that if it is maintaining the distance 4 meter, so the radius of the circular path is also 4 meter. Why it is 4 meter? Because if the B reaches at the center, I will show you here. Suppose somewhere the B reaches here. At this instant, A is somewhere, let's say assume here. So if A is here with a speed of 2 meter per second, B is here. At this instant, the distance between A and B is also 4 meter. So because of this reason, we can say that the radius of the circular path is 4 meter. Now, I want to show you one thing. Just listen carefully. Okay, just listen carefully. If this angle is theta, understood? So this distance is also 4 meter. So this angle is also theta. So if the both angles are theta, so we can say that this angle is also theta and this angle is 90 minus theta. Understood? So for a constant, maintaining the constant distance between A and B, for maintaining constant distance between A and B, this is A, this is B. So between A and B, the velocity along the line joining between A and B is always constant. So the velocity along this line joining is always constant. So if you see the velocity VB component along this direction is nothing but it is VB cos theta, and VB cos theta is equal to the, you can say that somewhere this line is like this, it is not like this, so it is saying like here. So this line is, for better understanding, I clarify again. So suppose this is a circle and this is a diameter line. This is a point of line joining between A and B. So there is a line joining between A and B like this. Okay, somewhere, of course, and I show you. This is the point A and this is a point B, and this is the line joining between A and B. Okay, this is B, this is A, and A is moving in circular path with the center C with perpendicular length, it's with a speed of 2 meter per second, and the VB is moving here with the speed of VB. So of course, if I'm assuming this angle is theta, so this is also theta. So VB component along this direction is VB cos theta. Now we want to calculate this angle, because if you calculate this angle, we can calculate the component also. So just see here carefully. If this angle is theta, so this is also theta, and this angle is 90 minus theta. Understood my point? And this angle is also theta. So you can say that carefully. If you want to see, then this sum of two interior angle is equal to exterior angle. So with the help of this angle is nothing but it is equal to 90 minus 2 theta. Understood? Simply we can say that. Or you can say that, sir, this total angle is 90 minus 2 theta. So this angle is 90 minus 2 theta. Understood? Now, what is happening if you calculate the component of this angle along this direction, then component of this angle along this direction is 2 cos 90 minus 2 theta. So now I can write for maintaining the constant distance between A and B, the velocity of A and B along the line joining is always same. So we can write the VB cos theta is equal to 2 cos 90 minus 2 theta. Okay. So now you can write the cos 90 minus 2 theta is nothing but it is sine theta. So that is called 2 sine 2 theta. So VB is nothing. It is equal to 4 sine theta. This is the velocity of B. So the option is saying maximum speed of B. So for maximum speed of B, the maximum value of sine theta is 1. So if the maximum value of sine theta is 1, then VB is nothing. It is 4 meter per second. So the velocity of B we can very easily calculate. It is 4 meter per second. This is the first option. Now it is showing, our question is a maximum acceleration of B. So if you know the velocity, then for acceleration of B, the A is equal to dV by dt. So we can write it is 4 sine theta is nothing. It is cos theta into d theta by dt. And d theta by dt is what? It is r omega. Understood? So d theta by dt is the angular velocity omega, and omega is equal to, it is 2 by 4. That is called 1 by 2. So we can write here acceleration is 4 cos theta into 1 by 2. Or you can say that, sir, it is equal to 2 cos theta. So now the maximum acceleration is, it is 2 meter per second square. Why? Because the maximum value of cos theta is also 1. So we can say that the maximum acceleration is 2 meter per second square. So this is also correct answer. Now during a 1 revolution of A, the distance traveled by B is 32 meter. Okay, I want to show. Suppose this is a circular path of A and this is a diameter line. So once the A is here, the B is here, and A is moving in this direction with a speed of 2 meter per second, and the B is moving with a speed of V. At this case, this is 4 meter distance. And of course, Of course, this total distance is nothing, it is 8 meter. So now here it is reaches somewhere. At this time the B is reaches here. So again this distance is 4 meter. So now you can say that simply, if you want to see, then what is the distance? So 8 plus 4, 12 plus 4 is 16, and this is one side. So total displacement in one revolution, in complete one revolution, is equal to the 2 times of 4 plus 8 plus 4. So distances in one revolution is, it is d is equal to 2 times of 4 plus 8 plus 4. So that is called 32 meter. So distance is also calculated. It is 32 meters. So this answer is also correct. Now I want to write the modulus of velocity of a particle relative to other is constant. Okay, so now you want to go with the relative velocity. So now I want to tell you one thing. Again you can see, suppose I want to say this is a path of circular path of A, and this is a point of contact, or you can say that this is a distance line of A and B. Okay, so of course this is the A and B. A is moving here with the speed of VB or V you can write, and B is moving somewhere here with a speed of 2. I already tell you, if this angle is theta, then you see this angle is also theta, and this angle is 90 minus 2 theta. I already proved these things. So now for the better understanding, just see, if the B is observing A, then B is giving to speed along this direction, that is called V. Okay, so we can write the velocity of relative velocity of A with respect to B. So you can say that the VR is, so simply if you want to see, then one component along this direction, it is V sine theta, and this component is also 2 sine 90 minus 2 theta. So we can say that these velocities are added, because in this direction velocities are constant, in this direction velocities are same, so these velocities are balanced. So net velocity is V sine theta plus 2 sine 90 minus 2 theta. If I am talking about the maximum speed, then maximum speed is 4 sine square theta. Why? Because V I calculated already, it is 4 sine theta. So it is 4 sine theta into sine theta is sine square theta plus 2 cos 2 theta. So you can write, sir, VR is equal to 4 sine square theta plus 2 times cos square theta minus 2 sine square theta. So it is nothing, the relative velocity is 2 sine square theta plus cos square theta. So now relative velocity is 2 meter per second. So this is the relative velocity. Understood? This is simple. One thing I tell you, suppose if anyone have a confusion, so I already proved na yaar, V cos theta is equal to 2 cos 90 minus 2 theta. These velocities, because they are always maintaining the length, so the relative velocity is always along this direction. So these directions are same and parallel. Because of this reason, we can add these velocities. So V sine theta is the velocity of B plus 2 sine 90 minus 2 theta. Okay, thank you so much for watching this video.